All exterior wall design decisions start with the selection of a wall system and the standards set by your Sustainable Construction or Green Building program. This structure can be a collection of components or pre-manufactured product. Let's look at the most common wall structures being used today: standard wood framing, advanced framing, steel framing, precast concrete wall systems, poured-in-place concrete wall systems, structural insulated panels, and insulated concrete forms. We are all fairly familiar with stick-framed construction. Whether 2x4 or 2x6 studs, this technique has been used for more than a century. While offering excellent flexibility, we often overbuild with stick framing. There is an old myth that the more wood, the sturdier the structure. Actually, excess wood framing adds to the cost of construction and steals from the thermal performance of the building. It is best to optimize the amount of wood and use the appropriate number of studs to support the building. No more, no less. One way to do that is to use what is known as advanced framing techniques. New advanced framing techniques space studs at 24 inches on center and align the floor, wall, and roof framing members so we can use less lumber and still get the same structural performance. These techniques are proving to be a better choice for thermal performance and the efficient use of wood. This translates into savings for everyone. Also, with the rising cost of energy, we recommend the use of 2x4 walls with exterior foam sheathing or 2x6 walls with either foam or wood sheathing to provide a higher insulation value in all climates. In areas concerned about seismic and high wind events, houses are typically engineered and use additional structural reinforcement. This additional reinforcement may include one or a combination of the following: metal hold-down devices, pre-manufactured shear panels, shear walls, fully sheathed exterior walls, or site-built shear panels. For example, shear panels, either site-built or factory manufactured, can be integrated into a wood frame wall assembly to minimize racking and uplift. Site-built shear systems can also be incorporated using common framing materials. These site-built methods can be used for engineered applications, as well as in non-seismic areas, where code-required 4-foot wide bracing is hard to achieve, such as at garage door sidewalls. Due to the increasing cost of conventional lumber, as well as its reduced availability and quality, engineered lumber is becoming more popular. Engineered lumber is either finger-jointed dimensional material, or is similar to oriented strand board studs, and can be ordered in 2x4 or 2x6 widths. The use of engineered lumber is also a way to incorporate green building techniques into home construction. Green building techniques reduce waste and utilize our precious wood resources more efficiently. We're familiar with steel-framed construction in commercial buildings, and now we're seeing it used in residential buildings, primarily in southern climates where termites are an issue. Steel studs are lightweight, include recycled material, and don't retain moisture like wood. This can be both a benefit and a drawback. A steel-framed exterior wall tolerates less moisture than a wood-framed wall system due to wood's ability to absorb, store, and release water. Steel framing is also more thermally conductive than wood. It is important to cover steel framing with insulated sheathing in order to reduce thermal bridging and the potential for condensation. The amount of additional foam sheathing required depends on your climate. If you want to incorporate steel studs in a cold climate, we recommend using them only for interior walls. Precast concrete wall technology is creating more interest in above-grade applications as an alternative to wood frame construction. The precast panels consist of rigid foam insulation and fiber composite connectors, sandwiched between two widths of 5,000 psi concrete. This combination of materials creates insulated panels that are structurally durable and take optimal advantage of the thermal mass effect of the concrete. Some precast systems come with electrical conduits, blocking, and structural headers precast into the panels. Key requirements for these walls include engineering for proper reinforcing and a crane to facilitate panel installation. Poured-in-place concrete systems provides the forming contractor the ability to offer an insulated wall using their existing forms for both above and below grade applications. This system consists of a prefabricated rigid foam insulation centered in the middle of the form using a fiber composite connector system. Like the precast concrete system, this creates a durable insulated wall that also takes advantage of the thermal mass of concrete. Structural insulated panels, or SIPs, have been around for decades. They consist of a foam core sandwiched between two pieces of rigid sheathing. The combination creates a panel that is structurally sound, air-sealed, and insulated all in one step. Because they are factory assembled, SIPs can help you build faster, reduce labor cost, and lower construction waste. For example, the exterior walls in this 2,000 square foot home were assembled in 2 days, creating a wall system that is fully insulated, sheathed, and ready for windows. If you choose to frame a building with SIPs, we recommend that you select a foam that is treated to reduce the possibility of termites and insect infestation. The product used in this home incorporated a borate-treated foam core that not only repels insects, but also reduces the potential for mold growth. A key requirement for a SIP wall system is the careful application of durable sealants and the installation of sufficient fasteners to provide a proper air seal and ensure structural integrity. Insulated concrete forms, or ICFs, is another wall assembly in use today. It can be used both above and below grade. This wall system is composed of concrete sandwiched between 2 layers of foam. The result is a strong, quiet, energy-efficient envelope. Of course, like all other systems, ICF walls must have waterproofing and a proper drainage system when used below grade. An appropriate weather-resistive barrier or drainage plane must also be installed when used above grade. Another benefit of ICFs is their higher thermal mass and ability to handle higher wind loads. Some ICF products are also treated for termite resistance. Each of these exterior wall structures requires a properly designed and installed system for managing rain and moisture flow.